Okay, we're starting with form and pour mortars. Everybody know what form and pour mortars are? I mean, you know, by the opposite of that would be a hand patching material. Okay, we're not talking about hand patching. We're going to show you 3 materials today. 2 of them are pre-aggregated, that is, the aggregate comes in the bag, and they're used for deep repairs. Deep repairs on the top side of a deck, or on a column, or even on the underside by using temporary forming. You can pump these repair mortars, or you can simply use head boxes. A head box is like a big funnel, pour into that, and it flows. Charlie's going to show us the first one. He's going to show us the slump on Planetop 11. Planetop 11 is for deep repairs, 80-pound bag, 1 inch to 8 inches, okay, full depth repairs, typically, okay. 80-pound bag with its own rock in it, mixed simply with water. Drill it up or use a mortar mixer. And you're counting on the material to flow and to fill in the void. So if you're enlarging a column, you're making it larger, you're jacketing it or whatever, you're going to build your forms around it, and you may just use gravity and drop it in from the top. You could also pump it in if you want to. This is Planetop 11, about 2,500 psi in 24 hours. Low heat of hydration, so it's not burning up a lot in the hydration process. It's not creating a lot of heat within the forms. And you can use it to build underneath a beam enlargement, or like I said, columns. Or imagine a PT deck, post-tension deck, and you've cut out all your bad areas per ICRI recommendations, and you have your mortar ready, and you can just throw it right back in the hole and screed it off. A lot of garages get that kind of work and this particular product before they put down a membrane. High strength, about 6,000 psi, 28 days. So Charlie's going to go through how you test slump. This is it's a material that gives you an 8-inch slump. You'll get to see what an 8-inch slump is and how you properly test for that. You notice the process. Pour it into the cone, and then he's going to begin the consolidation process. The STM test calls for consolidating it with a rod. Then another layer of material, rodding again, and then a third time. And then he'll strike off the top, he'll lift the cone, and we will measure the slump, okay, and the process for doing that. Once again, the purpose is for you to appreciate the viability of these products, to facilitate installation in a variety of ways within forms or on a deck, where you're just using the actual void in the deck to repair, to be the forming. Charlie's going to lift it now, lift the cone vertically, slowly. And he's going to measure the slump. And we're going to find here, looks like he had a little wetter mix this time, or he 9.5 inches. So the mix this morning was 8-inch slump. The second test, 9.5. Could be a function of a little bit more water, or it could be a function of just drilling and shearing the plasticizer so it was much more effective. Now this is the 11 SCC, once again used for enlargement, beam enlargement. Or let's say you've got an area that's hard to get to and you need something to flow back and around a corner to fill an area that was blocked out on a bridge deck or whatever. That's what this is for. Super high flow, has lots of interesting properties. Corrosion inhibitor, silica fume, polymer modified. So we've moved up in terms of performance, not only in this flow you're going to see, but in the ingredients within that fight corrosion and give you high strength at the same time with low water ratio, water to cement ratio. So the filling the cone again, different method, no rotting. You shouldn't have to rot an SCC. By the way, SCC again means self-consolidating concrete. And it's a structural repair mortar. That means when you look at the physical properties of that product on its technical data sheet, you will see that the modulus of elasticity, you go ahead and pull it, the modulus of elasticity, and all of the various things that you need, curing, shrinkage, resistance in the case of coulombs, which is really important, which is a measure of density. These things are built into this so it flows and it gives you the structural strength you need, perhaps around a corner into that block up. Go ahead. So who's going to measure this? Let's see what we get here. 24 inches. Bang on, just like this morning. Okay, so that's what we had this morning too. So we're at 24 and a half. We take two measurements, add them, divide by 2, and that's our average, okay? The third one we're going to show you is an unaggregated material with super, super high flow, okay? Now, it's unaggregated, so we can't go the full 8 inches without extension. Okay, if we're going to go beyond 4 inches, we need to add 50% pea gravel as a heat sink within the material to bring down the heat of hydration. This is one we did earlier. We poured it against plexiglass, and that's what you're going to get. You're not going to get bug holes, you're not going to get voids, and it's going to consolidate around all the steel, even if it's congested, and give you a structural repair. The last thing you want when you're doing structural repairs is to have a hollow or a lack of consolidation. There's nothing attached to the bar in those areas. Water can get in, a corrosion cell can start, and you're back to where you started in a couple of years, and you'll have to tear it out and start over. So what we're simulating here is a congested bar situation. We're going to pour it into the form. You'll see it flow, come back up on the other side, and consolidate just like we've done here. Planetop 15, 55-pound bag, unaggregated, polymer shorts, fiber shorts, shrinkage compensated, excellent product for beam enlargement, column enlargement, those difficult pours where you have to go back in, and as I said before, around corners and down to fill out blockouts that you might, I have found on bridge decks. So the guys are bringing the next batch out. It's very fluid, a very fluid material, and that's what you want. Let's say we had a 20-foot beam, and we start at one end with our spout, our entry port, head box, and we've got to run at 20 feet. Obviously, this one will do that. It'll run 20 feet, 4 inches thick, push itself out that exit hole, driving the air out, and when it cures, it'll be part of that beam. And that beam will be enlarged and therefore strengthened. It's used a lot for that. I've used it a lot in Hawaii on the Ala Moana Mall. Some of you may be familiar with that. It's a dredging project, and we're doing a lot of beam enlargement there as the mall is being modified. Once again, a fluid mortar, much more fluid than the others, right? You see the aggregate in the 11 SCC. This one can be aggregated. You can add 50% extension 3/8 pea gravel if you need to, if you're going over 4 inches. But to have that beautiful maximum flow to run 20 feet or more, and you're going, let's say, 2 inches, there's no reason to add the aggregate, and the aggregate will slow the flow. I mean, it's a natural thing. The other thing is there are thickening agents within that keeps that aggregate in suspension. So when you look across here, you don't see its own, small, larger sand pushing out through there. So everything is uniform, unsegregated, and a beautiful way to do form and pour structural repairs. Anybody have any questions? Anyway, thank you for attending.